Alright, so in my previous example, I had this funky thing going on x equals -2, and that was because originally in my function, I would have to have something like x squared minus 9 over x plus 2, because I know that when I divide, I can't divide by 0, so when I divide by 0, funky stuff happens. So in this case, x cannot equal -2, which is why that becomes a factor in my denominator. It's not going to be exactly this part in the numerator for that particular graph, but I'm just giving you a rough idea of what things you might have had, so that way when it factors up top, you would get x plus 3 and x minus 3 all over x plus 2, where it would not cancel with the top and the bottom, leaving you with a hole. It would leave you with an asymptote. Alright, for all rational functions, if the end behavior is a numeric value, the value will be the same as x approaches infinity and negative infinity. In addition, the end behavior for all rational functions can fit into 3 categories. The examples are provided below. So, one of those examples is on A. I've got x over x squared minus 5x plus 4. So I know that with our end behavior model, which tells me what's going on at my very, very ends if I didn't have this graph sitting here. My graph tells me at the very, very ends on my left and my right, I should be approaching 0 from both sides. How I would get that without the graph is I would look at that end behavior model, which is just when I look at my first two terms, which would just be end behavior model, which is just x over x squared. Alright, and that just simplifies to 1 over x, which tells me that my denominator grows faster and faster and faster, which means that I would be approaching 0. And hey, on my graph, that idea matches here. So graphically, that lines up. So I would have my limit as x approaches positive infinity, meaning I'm going off to the right. Again, so as I approach positive infinity, my y values are going towards 0. And my limit as x approaches negative infinity, meaning I'm going off to the left. My x values are going off to the left. And with off to the left, my y values are getting closer and closer to 0. Alright, that's cool. But what about my other numbers? Like, what about, you know, we look at that previous example and I'm like, wait, that same type of deal's going on here because I've got one piece going straight up and I've got one piece going basically straight down. So how do I know where these vertical asymptotes are? Well, again, vertical asymptotes are based off of where the denominator does not cancel. So if it does not cancel, that means that I've probably got to factor my denominator and my numerator if it's not factored already. So this would factor to being x over x minus 4 times the quantity of x plus 1. Alright, again, x does not cancel with anything in the denominator, leaving me with vertical asymptotes sitting there. So I would also know that I've got limits as x approaches positive 1, for example. Whoops, that should have been a -1. I apologize. And so I know that my limit of x approaches 1. Well, the problem is, at 1, again, I've got this vertical asymptote going on. Let me go find my head. So going up here, I've got, this number going towards infinity, and then down here, I've got a completely different number, but both sides, I'm approaching 1. So what happens? Well, in this particular case, I would actually have to have 2 limits for one number, which to us sometimes is unfortunate, but not completely. So, since they're both approaching 1 as an x value, how do I denote from the left and the right? Well, if I'm coming from the left, I'm going to write my 1 like I have, and I'm going to denote that with a minus, saying, hey, I'm coming from the left. I'm coming from, like, negative values or numbers that come before. Alright, so limit as x approaches 1 from the left, well, from the left would just be this piece here. And this piece here is going up and up forever, which means that my y values are approaching positive infinity. Alright, that's nifty, that's cool. But I also have this limit as x is approaching 1 from the right as well, because I said, hey, this piece is going to be going down. So how do I know it from the right? Well, if minus indicates from the left, a plus sign is just going to indicate from the right. So as my x values are approaching 1 from the right, my y values are going down forever, which would be negative infinity. Alright, cool. That's it. That's all there is to it. Alright, so my other asymptote would be at x equals 4, which it is. Alright, that also means that I need a limit as x approaches 4, but again, same type of deal going on here. One of my pieces going up and up and up forever, and one of them's going down forever. So what the heck? Well, because I have two different pieces, I need two different limits again. So as I'm approaching 4 from the left is going to be this piece here. Alright, how I'm going to note that I'm coming from the left is I'm going to put that little minus sign there saying, hey, my x is approaching 4 from the left. And what are my y values doing? That's what that's going to equal. Well, my y values are going to equal negative infinity. Okay. And then my limit as x approaches 4 from the right, which I indicate with a plus. Plus is always from the right. Alright, so as I'm coming from the right, but I'm approaching positive 4, my y values are going to go up and up and up forever, indicating that my y's are going to go towards infinity. And that's really all there is to that. Alright. Not bad at all. Alright. See you guys in my next video.